Okay, welcome back, y'all. Today we are going to be looking at our Day 2 notes for Unit 12, Acids and Bases. Before we go ahead and move on to Day 2, though, there was something I forgot to include in the Day 1 notes, so I want you to go ahead and flip to the page that has the capital B, A, D at the top, our Bases Accept, Acids Donate memory device. So go ahead and flip to that page because I want you to add a note here at the bottom by your strong bases and acids and your weak acids and bases. So for your strong acids and bases right here, what I want you to do is I want you to make yourself kind of a little bracket so that way you can write this note to the side. I want you to write that strong bases and strong acids fully ionize in water. So strong bases and strong acids will fully ionize in water. And remember, ionization, that is when we are breaking our acid and base into its ions. Now, for your weak acids and bases, I want you to go ahead and draw an arrow to weak acids and bases, and I want you to note that weak acids and weak bases, I am abbreviating weak acids and weak bases as WA and WB, these do not fully ionize. Okay? So weak acids and weak bases do not fully ionize. So what that means, and I drew y'all a picture to help illustrate that, is that if you have a weak acid, like hydrofluoric acid, for example, or a weak base, it's not going to completely separate. It's not going to completely ionize or dissociate. You're going to be left with some of the pieces still stuck together and some of the pieces separated. So right here we have our hydrogen ion and our fluoride ion, and then we still have some of these pieces right here stuck together. That's what happens when you have a weak acid or a weak base. They don't fully ionize or dissociate. Now, if you have a strong acid or a strong base, I gave an example of a strong acid here, hydrochloric acid, you are going to completely ionize. You're going to completely separate. So you'll notice here, we don't have any chunks stuck together like this drawing over here. These are all separated. So that's what it means to completely ionize or to completely dissociate. Okay? So I want you to be familiar with that, be able to identify pictures that showcase this phenomenon. And if you have any questions, again, always come and ask one of the chem teachers. We are happy to help. But that is all I wanted to add for the Day 1 notes. If you are done looking at the picture here, I'm just going to kind of leave it on screen in case you want to pause it, maybe draw your own. If not, we're going to go ahead and move on to Day 2. So I want you to go ahead and flip to Day 2, which says Neutralization Reactions, pH and pOH. Okay? So throwback to reactions. We are going to be writing some reactions today, like we did in one of our earlier units. We are specifically only going to be writing reactions with acids and bases, though, which is going to involve, you guessed it, an acid and a base. So the example here that we are going to work with is sulfuric acid and lithium hydroxide. Okay? So I'm going to go ahead and write that out. Our reactants, the part on the left side of our equation, we have sulfuric acid. You'll remember that ic ending means 8, so sulfate, which is SO4 with a -2 charge. If you need to look up on your periodic table what sulfate is, that is perfectly fine. That is why we have that as a resource for you. Let me go grab a periodic table. Okay, and I'm back in my periodic table. Remember, your polyatomic ions are always on the back right there for you to reference. So we have sulfate, and since it's acid, we of course had to use 2 hydrogen. Hydrogen has a +1 charge to cancel out the -2 charge on our sulfate. Now hydroxide, remember hydroxide is OH with a -1 charge. And so lithium has a +1 charge. So we just needed 1 lithium and 1 hydroxide to cancel those out. So these are our reactants. Be able to look at a name and write out the formula, and vice versa. Be able to look at a formula and write out the name. That's what we were practicing with last class. And once you've written this out, you should notice that this looks very familiar to a reaction we talked about earlier this year. This looks very similar to a double replacement reaction because it is a double replacement reaction, okay? So remember, with a double replacement reaction, our cations or our anions switch. So the hydrogen is going to go hang out with the OH, and the lithium is going to go hang out with the sulfate. So the products then, if we're going to predict that switch, are going to be lithium sulfate. And again, remember lithium has a +1 charge. So this is what we end up with when we pair that sulfate with the lithium. So we have lithium sulfate. And over here, we're going to go pair up the H and the OH. Okay? You'll remember that hydrogen has a +1 charge. Hydroxide has a -1 charge. You're going to need 1 hydrogen ion and 1 hydroxide. And oh boy, wouldn't you know it, it is water, H2O. Okay? So these compounds that we are going to form when we react this acid and this base together is going to be a salt and water. Okay? So right there, there's my water. Y'all know what H2O is. And there's my salt. So this doesn't necessarily have to be, sodium chloride. This is just an ionic salt. Lithium sulfate is an ionic salt. Okay? So if we put all this together, we can write our full reaction. We're going to have H2SO4, our sulfuric acid. We're going to have lithium hydroxide. I'm going to leave some space for balancing. SO4 plus H2O. And I didn't leave space there. Okay, so that is my skeleton equation. So it's not balanced, but I wrote it all, put it all together, and that's what I got. Okay, and this pattern that we see right here is going to repeat consistently. Every acid-base reaction that y'all will deal with, please remember that you're going to have your acid and your base on your left side, your reactant side, and then on the product side, you are going to make a salt and some water every time, okay? And if we wanted to go ahead and balance this, we could do this, okay? I'm going to talk about balancing water here. You might be a little hard-pressed to balance this, but don't worry, I'm going to show you a trick. Remember how I said water was just the hydrogen ion and the hydroxide ion? Well, we can actually think of H2O as HOH to make it a little bit easier on ourselves. Because you'll see over here you have H, and you'll see over here you have OH. Right here you have H2O, which is kind of a little weird. If you think of it as HOH, you can imagine instead that you have, right, 2 H's and 2 OH. Okay? So that helps me come over here and go ahead and put a 2 in front of my lithium hydroxide because I want to make sure I have 2 hydroxide on each side. So I have 2 hydroxide, one here and one here. And that also lets me have 2 lithium on both sides. I see right here I have 2 lithium here That 2 right there lets me include that. And then I already have 2 hydrogen over here. So we are fully balanced. If you would like to fill in the remainders with 1, that is perfectly fine. You don't have to though. Okay? So that's my trick for balancing with water. We'll do it again down here. I'm going to do 2 more examples with you so we can get some more practice. It is a little tricky, but you can do it. Okay? So we're going to go ahead and look at these equations right here. We are lucky they gave us the reactants. So all we need to do is switch our cations. So my H and my Na, my sodium, my hydrogen and sodium are going to switch spots. So that's going to give me sodium nitrate, because remember, nitrate has a -1 charge, and it's going to give me water, because if we remember our pattern, we're going to create an ionic salt and water. Okay? So right here, we're starting off with nitric acid. I think it is a good idea for you as you go through these. I'm not going to do all of them with you, but as you go through and practice on your own, I want you to write in the names of the acids and the base. It's going to give you some more practice with naming, which is what we started with last class. So you have nitric acid and sodium hydroxide, and then we are actually all balanced. I have 2 hydrogen over here, 2 hydrogen over here, 1, 2, 3, 4 oxygen over here, and 4 over here, 1 sodium on both sides as well. So we are already balanced. We can go ahead and put 1s there if we would like. You can also leave them blank. The next one we have here, we have sulfuric acid. And again, I want you to practice doing this as well. If you want to pause me right now and try and figure out what this one is, that might be a good idea. Okay, hopefully you were able to pause me and figure that one out. It is calcium hydroxide. Remember, bases are easy. We just have to name the metal, then hydroxide. Okay? So I'm going to go ahead and finish out this skeleton equation. I'm going to make my salt and my water. Okay? So my calcium is going to go pair up with the sulfate. Calcium has a +2 charge. Sulfate has a -2 charge. They cancel each other out very nicely. And we have some water. Okay? This one is a little tricky though with the balancing. We don't just get to put 1s in front of everything. Again, I want you to use my trick. Remember that water, you can also think of it as H and OH. So I see over here, obviously I just have 1 OH, but over here I have 2 OH. I've got 2 OH, and I've got 2 hydrogen. So I'm going to go ahead and put a 2 in front of my H2O, because that would give me 2 hydrogen and 2 hydroxide. Okay? And then everybody else is already balanced. I have 1 sulfate on both sides and 1 calcium on both sides. So I get to go ahead and finish this out by putting 1s in the remaining spots. Okay. That water trick is going to help you out if you have a hard time separating the OH and the H. This automatically separates it for you, so you can very easily determine how many hydrogen and hydroxide are on this side. Okay. So with that, I want you to go ahead and flip to the next page. I'm going to do one more with you. This is asking you to create a skeleton equation based off of a word equation. So again, this is just being able to look at this name and translate that to a formula. So we have hydrofluoric acid. If we have hydro and ic, remember, this is just fluorine. And lithium hydroxide. Remember, bases can be easy. It's just your metal and your hydroxide. Make sure your charges cancel out. +1 and -1 will cancel out. I'll even put that up here so y'all can visualize that. Okay? Remember that fluorine has a -1 and hydrogen has a +1. So that's how we get hydrofluoric acid and lithium hydroxide. And then again, using our basic formula, our lithium is going to go hang out with fluorine now. They cancel each other out nicely. And then we have water. There's our salt and our water. And this right here is just asking for the skeleton equation, so we don't have to balance this. If you would like to balance this, you're more than welcome to. This one is easy. You can pause me. Hopefully you pause me. We're able to see that this one balanced out very nicely. But no need to include the balancing since it is just a skeleton equation. So those are neutralization reactions. I want you to go ahead and do all of these other equations for practice. So there's several of them left. There's still 2 more on this page over here. So make sure you attempt those. It's going to be great practice for your quiz and for your test. But the quiz is first. And then the last thing I want to talk about today is pH. We're going to do a little introduction to pH, and then we're going to finish up pH and pOH next class, okay? So right here we have a nice picture of the pH scale. I told y'all on the first day of notes that the pH scale goes from 0 to 14. And if you are lower on the pH scale, you are an acid as you get lower and lower. If you are at 7, pH of 7 is neutral. If you are at 7, you are neutral. You are not an acid or a base. Sorry about that. I was kind of blocking the space. And if you are above 7, you are a base. And so we have lots of great examples of different acids and bases here. We have, again, a lot of our cleaners over here are going to be bases. Baking soda is another great example. Stomach tablets if you have an upset stomach. And then over here, battery acid, lemon, tomato, lots of fruits have acids in them. And then right here in the middle, we have water at neutral. Pure water is neutral. It has a pH of 7. And so what is pH? pH is just something that we measure, we use to indicate the concentration of hydrogen ions. The P in pH means power, and we can solve for pH with a formula. pH equals -log times the concentration of hydrogen ions. The brackets mean concentration. So that is why it is in brackets. Another formula we can use is the concentration of hydrogen is equal to 10 to the power of the negative pH. Okay? And just make a little note, brackets mean concentration. That's where that concentration comes into play. That's why we include our brackets here. Okay, so we're going to use these equations to help us solve some of these problems down here. We have just a couple today. Our sample problem 1 asks us to determine the pH of a 0.00012 molar solution of sulfuric acid. Okay, so what I'm going to do is I'm going to go ahead and write my equation. I'm given the concentration. This is concentration. We measure concentration in molarity. So I can solve for pH by doing -log times the concentration of that solution. So I'm going to go ahead and put that number in, 00012. Close off my bracket. And then I'm going to plug that into my calculator. So I'm going to grab my calculator and show you what that looks like. Okay? So you know where to go. So you're going to hit negative. This is the negative button. So click that negative. Then hit log right up here. It automatically puts a parenthesis, opens a parenthesis for you. And you're going to type in that concentration, just as we put here. Okay? 0.00012. And then I'm going to close my parenthesis. And I'm going to hit enter. Okay? That gives me 3.9208, a bunch of other numbers. We are just going to round to 2 decimal places. Oops, looks like my lights turned off. Those of y'all who have me in class know that they do this all the time. Okay, and we are back. Let there be light. So we are going to just round this to 2 sig figs right here. And that's our answer. Our pH is 3.92. Sample problem number 2 right here. We're going to do a little bit different equation here. So it's asking us what is the concentration of a solution with a pH of 6.1. So concentration, what is the concentration? We're going to have to use this equation over here. So our equation is that the concentration of our hydrogen ion equals 10 to the power of negative pH. So let's go ahead and plug that in. 10 to the power of negative 6.1. That's what our pH is. And we're going to solve. So our H plus, our concentration of H plus, we can solve that by typing 10 and then hit to the power of, so you're going to hit this little button here that looks kind of like the roof of a house, up, negative 6.1. And you're going to hit enter. Okay. And we get this. Now that is a very small number, so I'm going to go ahead and put this in scientific notation. To remind you, you're going to hit second, this DRG button. I'm going to arrow over to psi. That will let me have it in scientific notation. And again, I'm just going to round this to 2 places past the decimal point. It's fine. Oops. And I just realized up here I wrote 2 sig figs. This should be 2 places past decimal. Okay. So same thing here. 7.94 times 10 to the negative 7 molarity. Make sure to include our unit. Okay? So we went ahead and got the answer to that one. Now that we've had some practice using these 2 equations, we're going to talk about pOH really quick. pOH stands for the power of hydroxide. Okay? And so the pOH and the pH are going to be inversely related. So what this means is as pH goes up, pOH goes down. So our formula, if you were asked to calculate pOH, is going to be pH plus pOH equals 14. So these 2 numbers need to add up to 14. So if my pH is 8, let's do an example over here. Example, pH is 8. pOH has to add up to 14. So pOH is 6. Those 2 add up to 14. Okay. So that's all I have for you today. Again, I want you to go ahead and go back to that previous page. Make sure you are practicing all of these problems, that you're really comfortable with naming and writing formulas for acids and bases, as well as balancing, because you need to be able to do that for your quiz. If you have any questions, find yourself a chem teacher. We are happy to help.